Question 8 is about hydrogen peroxide and how it decomposes to form water and oxygen, and some of the catalysts that can be used to speed up that reaction. First question asks us to write a balanced chemical equation. Now all the information is already given in the question. Hydrogen peroxide has the formula H2O2, and that decomposes, and the question tells us that it decomposes to form water and oxygen. Water is H2O, and you need to remember that oxygen is a diatomic molecule, O2. Let's check balancing. 2 oxygens on the left, 1 and 2 more, 3 on the right, so that's not balanced, so we need a 2 there and a 2 there. That gives us 4 hydrogens on the left, 4 hydrogens on the right, 4 oxygens on the left, 2 and another 2, giving us 4. So there's our balanced chemical equation for the decomposition of hydrogen peroxide. Question 8.2 asks you to evaluate which catalyst is most effective, and the readings that we have here are time for reaction, and you need to remember that rate of reaction is proportional to 1 over the time. In other words, quite simply, the shorter the time, the faster the rate. And I think it's quite easy to see that MnO2 is the most effective catalyst, and the explanation is that the reaction takes place in the shortest average time for MnO2 compared to iron oxide and lead oxide. Question 8.3 asks you to describe how a catalyst increases the rate of reaction with the aid of an energy level diagram. So that means that you need to draw an energy profile as well as a written answer. Let's start with the energy profile graph. You remember that it's a graph of potential energy against the progress of the reaction, and we're told in the question that it's an exothermic reaction, and so our energy profile needs to show an exothermic reaction with the products at a lower energy than the reactants. And a catalyst simply provides an alternative pathway that has a lower activation energy. So you'd need to indicate that. Make sure it starts at the same energy and finishes at the same energy. You would indicate that that is the activation energy for the catalyzed reaction, and that is the activation energy for the uncatalyzed reaction. You need to indicate that a catalyst provides an alternative pathway. That's how it operates, an alternative pathway for the reaction to proceed along, and that alternative pathway then has a lower activation energy, and that's indicated on the graph with the height of those 2 humps over there. 8.4 asks you to explain why hydrogen peroxide can be used as a rocket fuel. And the key here is to remember from the balanced equation that when it decomposes, it releases oxygen gas. And so that's the first point, is that it releases O2 gas. And then secondly, to simply appreciate that O2 can be burnt as a fuel. Oxygen burns very well, strongly exothermic reaction, and can thus be used as a fuel.